would also like to express my gratitude for receiving this lectureship award from the Society for Endocrinology. So today, as was mentioned, I would like to talk about the interpretation of gestational thyroid function measurements, particularly focusing on some rather new ideas and concepts that we're now bringing out within our research group that focus on clinical risk assessment and also taking into account some considerations with regards to the pregnancy-specific physiology that changes thyroid function. So here's my conflict of interest slides, and here's the outline of my talk. So I'll begin by just getting everybody up to speed on thyroid physiological changes during pregnancy. Then we're talking about the concept of defining a normal and abnormal thyroid function, and also some of the changes that are going to occur in guideline recommendations. And then the basis of my talk will be about identifying high-risk individuals. I will be using two of our recent papers to take you along some of the thoughts we had while doing these studies with regards to the assessment of the full spectrum of thyroid hormone action. And I will use a study that we did on neurodevelopmental outcomes. And I will use a study on TPO antibodies, HCG, and the risk of premature delivery, recently published, to tell you something about some of our lines of thought with regards to clinical risks that may be conditional on whether or not there is also an abnormal physiological mechanism that underlies it. So this all sounds perhaps a bit difficult at the moment, but I'll take you through and finally come to some conclusions and share some future perspectives with you. All right, so with regards to thyroid physiology during pregnancy, here you can see a timeline starting with conception on the left, going all the way up to birth on the right. And what we know is that there is an increase in thyroxine degradation by placental expression of type 3 deiodinase, and also there's thyroxine transfer to the fetus. So this basically causes a form of consumptive hypothyroidism and necessitates an upregulation of thyroid function to maintain adequate thyroid hormone availability. So what we also see is marked increases in thyroxine binding globulin, which also cause an increase in total T4 levels. But luckily, there's also a peak in HCG levels, and as you can see, there's also a very steep rise from conception onwards. And HCG has, of course, a high homology with TSH, therefore has a weak affinity for the TSH receptor and actually stimulates the thyroid during early pregnancy. This is also reflected by the trajectory of free T4 levels, which slightly increase during early pregnancy, and this subsequently via the negative feedback system causes the classical dip in TSH levels during early pregnancy. So taking into account these large physiological changes, the definition of defining what's normal and abnormal in this field is really dependent on using a pregnancy-specific approach, because we really need to take into account these physiological changes. So guideline recommendations that I will be showing in my next slide actually advocate the use of population-based reference ranges. So basically you take a large population and you calculate reference ranges in there according to the principles of the Gaussian distribution depicted here on my slide. And then what you usually end up with is that you define the cutoff for low or high TSH or free T4 or other measurements by looking at the lowest and highest 2.5%. And then you have a binary outcome saying, is this normal or is this abnormal? So, as I mentioned, the current international guidelines advocate that you use this population-based approach, also use a trimester-specific approach, and do this in a population that is, well, at least in TPO antibody-negative women, but preferably also exclude other risk factors for thyroid dysfunction. Unfortunately, there's many labs and centers around the world that do not have such data available to calculate it on their own. And in order to be a bit pragmatic, the current international guidelines of the ETA, the ATA, and also the Endocrine Society advocate the use of fixed trimester-specific cutoffs for the upper limit of TSH if you do not have such populations available to calculate your own reference ranges. And the fixed upper limits are 2.5 in the first trimester and 3.0 in the second and third trimester. However, when you zoom in on the data that was actually used to come to these 2.5 and 3.0 milliunit per liter cutoffs, then these were quite marginal studies performed in small populations and also coming from around the world. So these 6 studies shown here were actually used to come to these 2.5 and 3. And what you can already see is that there's large differences in the cutoffs of these studies. So between these studies, the range in, for example, the first trimester was 2.30 to 5.0 milliunits per liter. So this made us look further into the literature, and 2 studies came out fairly quickly after the first guidelines by the ATA. Here on the left, the Chinese study investigated the association between TSH and free T4, because if you see concomitant changes in these markers, that may be a better way of looking at mild thyroid dysfunction in pregnancy. And what they found was that free T4 levels were actually very stable throughout a quite wide range of TSH, so between about 0.8 to 4.8. And if you look at the study on the right, this was done in the Generation R cohort in Rotterdam, where I've also done a lot of studies together with Marco Medici. And what he found back in 2011 already is that if we use these cutoffs in Rotterdam, compare them to a population-based reference range, we're approximately over-diagnosing women to have a high TSH in 9% of our whole population in the first trimester and 5% in the second trimester. So it seems that these 2.5 and 3.0 milliunits per liter are likely to cause over-diagnosis. So therefore, we summarized the literature, and we found 14 studies encompassing data of over 65,000 individuals. And this very large table here shows you our results, and I realize that the numbers may be too small to read, especially in the back. But if you look at the upper limits that were defined in this study, again, according to this population-based reference range, we actually found that in more than 90% of all studies, these upper limits were well above the 2.5 and 3.0 milliunit per liter cutoffs, again, implicating that we may be over-diagnosing a lot of women as having too high TSH levels during pregnancy. So luckily, the new ATA guidelines currently under review, I hope they will be published in this year, still advocate that you calculate population-based trimester-specific reference ranges in the first place, but they now have added a second recommendation that if this is not possible, it's probably best to adopt reference ranges that have been calculated in a population-based way, but perhaps not in your own population, but in a different population. Preferably with some of the same characteristics, because we know that, for example, ethnicity and BMI can change thyroid function, so you can take that into account. But more importantly is that they use the same assay, because between assay differences are even larger. Of course, there may still not be a study that is applicable or generalizable to the population that you and your center see, so therefore they also have still a pragmatic solution of providing a fixed upper limit for TSH, which has now been increased to 4 milliunits per liter. And this seems to make a lot of sense, because large studies performed in iodine-sufficient populations tend to find upper limits of TSH around 4.0 milliunits per liter. All right, so that's the bit I wanted to talk about with regards to defining normal and abnormal thyroid function. And I'm now going to go linea recta up against myself and also talk or up against the point of defining this binary outcome and looking at reference ranges by going into identifying high-risk individuals. And again, here you can see this Gaussian distribution curve, and I think it's important to realize that a biochemical reference range does not actually equal the risk of an individual to have an adverse outcome. So there's a big difference in having this reference range and having a green or a red number pop up on your computer as compared to doing a risk assessment for your patient. Because, of course, in endocrinology, we expect there to be a dose-dependent effect of differences in thyroid hormone, even if it's within the reference range. So if we look at these two individuals, depicted here by these arrows, then the individual that's just below the upper limit for example, TSH, is she really that different than the one that is just in the red area of the reference range? I don't think so. I don't think that seems to make a lot of sense. So when we think about doing a risk assessment and looking at the continuous spectrum of thyroid hormone action, more likely it is that the risk is shown by the Gaussian distribution in the currently shown colored-coded scheme. So that if you are in the middle of the population, you probably have a lower risk, and that this gradually decreases on a dose-dependent manner as you go more towards the outskirts. All right, so I would like to now discuss a study that we have done where we took this mindset and studied the association of maternal thyroid function during early pregnancy with offspring neurodevelopmental outcomes. So we've known for quite a long time that thyroid hormone is essential for early brain development. And if we again take a look at this timeline here that I showed you before, we know that thyroid hormone-dependent processes in early brain development, such as the neuronal cell proliferation, migration, and differentiation, are all thyroid hormone-dependent processes that occur already in the 5th week of pregnancy. However, the fetal thyroid is not fully functional till approximately the 18th to 20th week of pregnancy. So this means that there's a very important time frame during which pivotal processes in brain development that are dependent on thyroid hormone actually are dependent on the placental transfer of maternally produced thyroid hormones. So if we look at the focus in the field, and I've shown here some clinical studies, but the same can be shown for experimental studies, the main focus has always been on low thyroid hormone availability. Because of course we all know the classical cases of cretinism, congenital hypothyroidism, leading to overt cases of disability and brain dysfunction. But again, this was then translated to clinical studies focusing only on low thyroid function. Here you can see the maternal hypothyroxanemia has been a subject of studying, low maternal free thyroxine, maternal thyroid deficiency, etc. However, we wanted to, again, like I said, use this mindset of looking at the full spectrum of thyroid hormones. So what we did is we selected from the Generation R cohort in Rotterdam about 3,839 mother and child pairs for which we had data available on early pregnancy, thyroid function, and also IQ measurements. And in a subset of these children, in 646, we also had MRI scans available of the brain. So we were able to assess gray matter volume and cortex volume. And what we actually found was that if you look on the x-axis here, the full spectrum of free thyroxine concentration in early pregnancy, that there is an inverted U-shaped association with all three of these neurodevelopmental outcomes. So this, first of all, seems to suggest that there is an optimum for thyroid function and thyroid hormone availability during early pregnancy, and then in turn, that both too low but also too high levels during early pregnancy can have adverse outcomes for neurodevelopment of the offspring. So we also did an external replication study to find out if this was not something that only occurred in our own population, because of course it's important to realize that if you find something in a single population, similar to GWAS studies, of course, that it's not always generalizable to others. So therefore we did an external replication study in the face of the EU Thyroid Project, which was a Horizon 2020 grant focusing on iodine. We also have a work package in there with regards to pregnancy. So we used data from our own study, but also added data from the ALSPAC study from the UK and the INMA study from Spain. And by combining these cohorts, we had over 9,500 individuals, mother and child pairs, with thyroid hormone and child IQ and other neurodevelopmental outcomes available. And we actually replicated exactly what we found before. So this is unpublished data, and we found that low maternal thyroid hormone and high maternal thyroid hormone levels were associated with lower child IQ. And we also replicated this to another neurodevelopmental outcome, because we also found that both low and high maternal thyroid hormone levels during early pregnancy were associated with a 2.3 to 3-fold higher risk of the child having autism. So, why is this relevant from the clinical perspective? Well, again, I think we're the first to really show that there also may be detrimental effects associated with higher thyroid hormone level during early pregnancy. And if you think about treatment with levothyroxine during early pregnancy in a woman that, for example, has overt hypothyroidism, then of course we want to achieve the scenario on the left, where we treat this woman from the left side of the graph, from the lower side of this curve, to the optimum highest point of the curve. But what could be occurring if we give a too high dosage of levothyroxine is that we have actually the scenario here on the right, where we overtreat her, going all the way to the other side of the curve, and there's actually no net benefit of our treatment. So some very, very interesting work has been going on in the group from Cardiff by Peter Taylor, Colin Diane, and Oksemi Onyebuchi, and of course also John Lazarus, because in the CATS trial, they actually gave a quite high dosage. So they treated women with mild thyroid dysfunction during early pregnancy with 150 micrograms of levothyroxine, and it was a negative trial. So they didn't find any benefit with regards to child IQ at the age of 3. And some subsequent analyses are now revealing that there may also be, in the ones that really were overtreated based on their biochemical phenotype, some adverse risk with regards to ADHD and things like that. So this is currently ongoing, but will be really important in the field to get a grasp of the potential harms of treatment with levothyroxine during pregnancy. All right, so that was the first part about identifying high-risk individuals. The second part, I will be more focusing on how clinical risks may be conditional on factors that relate to having an abnormal physiology. So TPO antibody positivity in the literature has consistently been associated with a higher risk of premature delivery. And this is, for example, shown here by this meta-analysis, finding a 1.7-fold higher risk in TPO antibody positive women. So we then replicated this a few years later, finding the exact same risk and actually also finding a higher risk when we look at a more overt phenotype of having premature delivery before the 34th week. So this really seems to be a consistent association in the literature, but really to date the working mechanism of this remains unknown. And this may be important because it can help us distinguish which TPO antibody positive women within that group as a whole actually have a higher risk. So there's two main hypotheses that relate to these working mechanisms. So the first one is that the association is actually confounded by having a higher susceptibility to autoimmunity in general. So this higher susceptibility, perhaps via other autoimmune diseases, increases the risk of premature delivery, and because you have a biological higher susceptibility, you're also more likely to have TPO antibodies, and thus there occurs a spurious association of TPO antibodies with premature delivery. The second hypothesis is more related to thyroidology. I think thyroidologists tend to think more towards this hypothesis, and that is that thyroid autoimmunity causes lower thyroid function, and that is the lower thyroid function that is then increasing the risk of premature delivery. So we again took a bit of a different approach with regards to investigating working mechanisms, and we started off with investigating the effects of TPO antibody positivity or thyroid autoimmunity on the physiology of pregnancy. So here you can see the association of HCG levels that we measured in our cohort in almost 5,500 mothers, and on the y-axis are the 3T4 levels, and what you can see in the TPO antibody negative group, we found exactly what we would expect based on the biology. So higher HCG, more thyroidal stimulation is associated with higher levels of 3T4. But when we look at the TPO antibody positive women here on the right, you can see that there's absolutely no association. So indicating that there may be an impaired response of thyroidal stimulation by HCG in women that have thyroid autoimmunity. We also looked at the TSH levels. Again, in the TPO antibody negative women, we see what we expected based on the biology. So higher HCG decreased TSH levels, but again, in the TPO antibody positive women, we didn't find any changes. And overall, as we see throughout the literature as well, TPO antibody positive women also had higher TSH levels. So what does this come down to? Of course, we only have a single measurement here, so this is really difficult to relate to physiological changes in pregnancy, so we have to make some assumptions here. I think the most likely assumption of having this lack of thyroidal response by HCG in TPO antibody positive women is depicted here again by this timeline. So in TPO antibody negative women in red, we expect this 3T4 increase to occur because of this HCG stimulation, but we don't expect this to happen based on our data in TPO antibody positive women. So what you really see occurring throughout pregnancy, most likely, is that there is a lower area under the curve for thyroid hormone availability throughout the whole pregnancy in TPO antibody positive women. The same can, of course, be said for the TSH, which is unlikely to suppress in these women when the HCG stimulation is occurring. Well, actually, it's not occurring, of course, in the TPO antibody positive women. All right, I think the batteries have died. No, I'll go with the mouse anyway. All right, so we wanted to further stratify to see if we can identify, again, those individuals within the TPO antibody positive group as a whole to be the ones that have a higher risk. So here you can see each data point in our data set for HCG and 3T4 levels in the TPO antibody negative women. So what we then subsequently did was, again, run the regression analysis. So here you can see the overall association that I showed you before between HCG and 3T4 in the TPO antibody negative women. So this is basically the association that we would expect as a mean in a group. So we then subsequently here plotted the TPO antibody positive women, and you can see that within this group there's quite a large variation still going on. So it's not as if all TPO antibody positive women are in the lower part of this graph. So this means that there's a group of TPO antibody positive women that actually has the same HCG and free T4 levels that we would expect in the TPO antibody negative women, so unlikely to differ from the TPO antibody negative women. But there's also two other groups shown here in green and also in red. And the green group has actually quite a high free T4 for the amount of thyroidal stimulation by HCG that's going on at this time point of blood measurement. But the red group is, of course, the group of interest, because most likely these TPO antibody positive women have the most severely attenuated thyroidal response to HCG stimulation. So we color-coded these groups according to the distance from what we would expect in the TPO antibody negative women. So here you can see the colors that we used. So there were 4 groups based on the distance from the line. So we took a 1 SD difference. And again, we have the green group. Then there's a yellow group slightly above the mean for TPO antibody negative women. The orange group slightly below the mean. And then the severely attenuated group again in red. So when we now look at the association of TPO antibody positivity with premature delivery, above you can see the overall association, basically the baseline risk of TPO antibody positive women for premature delivery in our population, which was, again, this 1.7-fold higher risk. But if we now stratify these women according to the group that I just showed you, the color-coded groups, we see that the TPO antibody positive women that are in the green group actually do not have a higher risk of premature delivery at all. The women that are slightly above the mean seem to be quite similar with regards to their risk according to the baseline number, but the ones that were below the line, and especially the red group, seem to be the ones that are putting the association in the whole group because they had the highest risk of premature delivery. So there's one methodological issue here, and that is that we only have a single measurement of HCG. So if you measure a low HCG once, we cannot necessarily extrapolate that to when a woman would have had a higher HCG. So we also looked at the women that only have high HCG levels, because in those women we are certain that we would have expected at least thyroidal stimulation to occur. And what we find if we look at these higher HCG levels, so the highest all the HCG levels above the median in our population, that actually the women that are in the green and yellow group do not have a higher risk of premature delivery at all, whereas those in the orange and red group have a 2.3 to 2.8-fold higher risk. Again, seemingly to pull the whole association, to pull the association in the group as a whole. All right, so that was the 3 points I wanted to make. With regards to conclusion on them, I think previously recommended TSH cutoffs really are too low, and there's a lot of evidence there. So we really should shift to preferably calculating our reference ranges in a population-based manner, or if that's not available, adopt population-based reference range from other populations, or use the 4.0 milliunits per cutoff, because they seem to be much more specific to define at least biochemical abnormalities. I think I've shown that both low and high thyroid function may lead to suboptimal neurodevelopment of the child. And I think it's important to realize, again, that when you initiate levothyroxine treatment during pregnancy, it's important that you are at least aware of the potential harms of overtreatment. Thyroid autoimmunity seems to impair the thyroidal response to HCG stimulation, as I show you in the latter part of my talk, and perhaps this deviation from normal physiology is actually the underlying mechanism through which thyroid function, or TPO antibody positivity in this case, is associated with adverse outcomes. So with regards to future perspectives, I think it will be important that we try to combine efforts to study the risk of disease and also especially identify thresholds for disease, because you have to imagine that TPO antibody positivity occurs in roughly 6 to 10% of a population, premature delivery in 7%, and then high TSH levels also in about 5 to 10%. So it's really difficult to study this, and you need really large numbers. So this is also one of the reasons that we in Rotterdam, together with the group in Cardiff, have founded the Consortium on Thyroid and Pregnancy, where we're inviting everybody that has data on thyroid function in pregnancy to contact us, and we're also actively contacting people who have published on it to combine their data and do very large studies practically, or probably we will be doing this in more than 100,000 individuals, giving us the statistical power to no longer define abnormal based on these biochemical abnormalities and the curves I show you, but really on the risk of disease. And maybe the risk of disease starts to go up in the highest 5%, for example, and hopefully we can find that out when we're doing those studies. I think it will be very relevant for the field to further identify mechanisms underlying the risk, specifically deviation from normal physiology. So I've showed you some of this data on HCG, thyroid autoimmunity, but other potential factors for this could be endocrine disruptors and iodine status. And of course, this is a bit straightforward, but more randomized controlled trials are needed, and not only to show the potential benefits of levothyroxine treatment, but particularly also to identify if there could be any harms. And of course, as I said, the group in Cardiff is now working very hard on that, and look forward to seeing that data. So here's my final slide. I would really like to thank the Society for Endocrinology for awarding me with this Early Career Clinical Lectureship Award. And I would also like to thank them a lot for the opportunities that they give to young endocrinologists. So actually my first ever medical congress was the BES, I think it was in 2010 in Birmingham. I did my first poster presentation. The year after that, I think it was in Harrogate. And this was all funded by the Society for Endocrinology, and also other conferences that I went to were also sponsored by them. And that really enabled me to do all of these studies and get all of these contacts to set up, for example, the Consortium on Thyroid and Pregnancy. So many thanks to them. Also to Robin Peters and Theo Visser, my mentors that basically set up this whole research line when I was still in medical school. Also the co-authors and professors of gynecology, child psychiatry, Marco Medici, Lael Schaker, Erik Stegers and Henning Thiemeyer. And I'd also like to thank Nikki Karavataki and Ashley Grossman. As was mentioned in the introduction, I spent about 6 months with them in Oxford, and they really infected me with their love for endocrinology and research. So I would like to thank them for being here in the UK again, and then also thank my other collaborators and our thyroid division, and of course you for your attention. So thank you very much.
Thank you, Tim, for a really wonderful talk, for taking us through the physiology of thyroid disease in pregnancy and the challenges that we still have as physicians. We very much look forward to your future work, and so please do report back. Best of luck in, when you go to Harvard, and once again, congratulations for this prize.
All right, thank you very much.